Good morning, all of you. So, as we know, we are studying chemical properties of organic compounds. In last class, we have studied already about combustion. So, combustion also is to called as what? Burning.
Burning.
Yes or no? So now, in this combustion or burning, we have been studied combustion of. If you take like all the organic compounds, that is what hydrocarbons. We used to say three categories. That is what based upon the number of carbons, carbon percentage. That is what saturated, and another one is unsaturated. Alkanes, alkenes, and as well as alkynes. So, in these two, they both are called as unsaturated, so that their carbon percentage is what, guys? Carbon percentage is greater. So they will undergo the oxygen which is present in the atmosphere is not sufficient for complete burning. So that is the reason they are not efficient fuels. But alkanes, if you have taken, due to the less percentage of carbon, they are very, very good fuels or efficient fuels. Is it yes or no? Everyone? So they will burn with a blue color flame, blue flame, as well as a non-sooty flame. So that is what we studied in the last class. But if you take alkenes and alkynes, they will burn with a sooty flame or non-sooty flame. They will burn with a sooty flame because a complete oxidation cannot be takes place because oxygen present in the atmosphere is only just 21 percentage. So this oxygen is not sufficient to burn these unsaturated hydrocarbons completely. So that is why whenever they will react, they will burn in the atmosphere. So they won't burn with a non-sooty flame. They always will produce as the a black unburnt carbon will be remaining. That is what we used to study in the last class. So if we'll take here, but if you'll take this unsaturated hydrocarbons, if you burn in the presence of pure oxygen, understanding, if you burn in the presence of pure oxygen, then they also will produce what? Sooty flame or non-sooty flame? Everybody? They also will burn completely, producing a blue flame without any smoke at all. That is what, if you burn under the presence of pure oxygen, they also will produce the blue flame without any smoky. That is what you have to remember it. So when they are burned at pure oxygen, but basically in the atmosphere only we can burn. So that is why they always will produces the smoky flame because the oxygen percentage which is present in the atmosphere is not sufficient for complete burning of unsaturated hydrocarbons. That is why their flame is, what is the color of their flame? Unsaturated hydrocarbons.
Yellow.
Color of that?
Yellow.
Yellow and sooty flame. That is what you have to remember it. Now, as we discussed, if unsaturated also can burn with a blue flame only under the presence of what, guys? When they have been reacted with the pure oxygen. Yes or no? So now let us take one example so that it will be clear. So you might be studied one of the first alkyne compound. Anybody can tell me the name of that? I want the name of that one. First,
Ethane.
yes, please, all of you. Ethane. This is the general name. I want the IUPAC name. Sorry, common name. This is the IUPAC name. Common name I want. Anyone? Yes, please. What is the common name? Mr. Elmukil, this is what you people are studying. It's a common name of ethane. None of you knows? Sai?
Acetylene.
This is what people are studying. Exam 100% they'll ask acetylene only. Even I told you so
Sir,
many.
acetylene.
Yes.
Acetylene.
Now you are saying. So acetylene. So if we'll take this acetylene or ethine, is it a saturated or unsaturated hydrocarbon? It is the unsaturated hydrocarbon. Do you understand all of it? So now, if I'll burn this unsaturated hydrocarbon in air, burn in air, so is it will produce sooty flame or non-sooty flame? That is what I want. Yes, please.
Sooty.
Yes, it will produce us very high sooty flame. We'll get like complete black smoke, sooty flame because of complete combustion or incomplete combustion. Yes, please.
Incomplete.
Because of incomplete combustion. When you are not studying the common names, you will never supposed to score good mark in this chapter. Again and again, I'm saying those who can capable to learn all the common names and as well as IUPAC names, only having chances to get full mark. So remember, I have taken a alkyne group called as a first member of alkyne group called as ethine. If I burn this one in air, because of incomplete combustion, it will produce very, very high sooty flame. So now the temperature of flame produced also is not high as it is most of the sooty flame is producing. So remember always blue flame is only high temperature. If it is producing yellow flame, so is it very hot or low temperatures? Hot temperature, hotness is. So blue flame is always producing extremely hot compared to the yellow flame. So yellow flame, low heat only will produce us always. Remember, that is why while you are cooking in your home, you can see, suppose one time your mother is cooking with the help of firewood, one time with a gas stove, where you will feel that better to cook and where it will be fastly over. Everyone?
Gas stove.
Gas stove. Because there it will produce blue flame so that the heat energy produced by it is extremely high so that it will be fastly completed cooking. So that is why the temperature of a flame produced here, whatever, that is what we'll say in the form of hotness, the temperature is also not high, means the heat produced also is not that much in the case of acetylene. But if you take any kind of alkane, their blue color flame only it will be producing. Now if we'll take here, if a mixture of acetylene and pure oxygen is burned, remember before I burned in where, guys? I have burnt in where? I have burnt in oxygen. I have burnt in where? Acetylene. Tell me. I have burnt in air so that the oxygen supply is not sufficient. Only in air, 21% of oxygen is there. So it is not sufficient for complete burning. So that is why it is leads to producing very high sooty flame with the low temperature. Now I'm taking a mixture of, if I have taken a mixture of acetylene plus pure oxygen. Now you tell me, is it will go under complete combustion or incomplete combustion? Everybody. Yes, please.
Complete combustion.
Complete combustion. Understanding? So complete combustion, so that it will produce what color flame? Sooty flame or non-sooty flame? All of you.
Non-sooty blue color flame.
Yes.
Non-sooty blue flame.
Yeah. So acetylene or ethane, so if I have taken, it will produce non-sooty flame and also it will be complete combustion. So blue flame it will produce. So with a high temperatures and low temperatures. Yes, high temperature. So only the availability of oxygen will decide whether it is a complete combustion or incomplete combustion. So the oxygen acetylene flame, that is what we used to call as oxyacetylene flame. All of you should remember a mixture of acetylene and pure oxygen is burned, then acetylene burns completely, producing a blue flame. So that is what extremely hot and produces very high temperature, which is used for, we are using in our daily life, welding metals. So that is now might be understand all of you. Welding time, you might be notice the person will wear a mask in front of his face and used to weld it so that it will producing very hot spark. Have you noticed it to joining the metals? All of you?
Yes, sir.
Yes. So that is what we are using. So the acetylene and pure oxygen cylinders both will be separately kept. Once they will be both burnt, understanding at a time, so that extremely high temperatures will produce us with a blue flame. So that is why we are using this one to joining the, that is what welding the metals. So that is why this mixture of acetylene or ethane and pure oxygen is called as oxyacetylene flame. All of you should remember oxygen acetylene flame, or we will say oxyacetylene flame. All of you write it. Oxyacetylene flame or oxygen acetylene flame. So because of producing high temperature using in welding metals. Hope everybody clear now. So a mixture of acetylene and air is not used like normal. If you'll do that in a normal air, so that it is not burning completely, it is not producing very hot or high temperatures. But if the same acetylene is mixed with the oxygen, pure oxygen, then it is produces a very high temperatures, which is used for welding the metals. That is what you have to remember. But here, remember, we are not using, we can use it for welding metals, but acetylene and ethane is not used for acetylene and air is not used for welding, because burning of acetylene air produces very sooty flame, so that it is not enough to melt the metals for welding. So that is why always, instead of burning the acetylene air, always will burn the acetylene with the help of what, guys? Acetylene always burn not with the air. So it is not used for welding. So only one reason. What is the reason behind acetylene air? Because it will produce as low temperatures and sooty flame. So that is why it is not fit for welding. So always we'll use what method? Acetylene with what? Pure
Pure
season, so that it will produces extremely high temperature, okay, with a non-sooty flame. So that is what smokeless flame. So it will produces very high temperature. So that is the reason we can use it for welding the metals. So if you'll go welding shop and all, you can see this acetylene cylinders or ethane cylinders along with the pure oxygen cylinder, so that both they will mix at a time, they'll burn each other, so that it will produces very high temperature for joining the metals or cutting the metals and all. So that is why the most common fuels containing high percentage of carbon is obviously very important to burn them completely in the presence of oxygen. So if not, what will happen? If they are not burning completely, so that what will lead, guys? Anybody can tell me? If they are not burning completely, what will happen? All of you. Yes, please.
black smoke.
It will leads to so many pollutants. So that is why we have to burn them very completely. If incomplete combustion of fuels, always we are having so many disadvantages. So that is the reason even today we are facing the biggest problem like air pollution, water pollution, land pollution, everything because of only fossil fuels burning. That is the major disadvantages for our society or our nature. Of course, we might be using for transportation and all the things today, energy generation with the hydrocarbons, energy generation with the petroleum products. Without that, we cannot. As we know, all the petroleum products are what? Hydrocarbons only. But because of this incomplete combustion, insufficient supply of air, it leads to unburnt carbon in the form of soot, which pollutes the atmosphere. That is what you can see. That the soot is very, very finest carbon, which will be even deposited in the lungs, also leads to lung cancer and respiratory diseases. So much difficulties in atmosphere and all. Even animals also, it will cause us a lot of problem. So it will, and also it will blackens the cooking utensils, and you can see the backside of this bowl, it will be becoming a very, very blackens if this incomplete combustion. So that is the reason, if you are burning with the, if you are cooking with a firewood, if you are cooking with a gas stove, where we are observing that utensils become black, that the bottom surface. Yes,
Firewood.
fire, because their incomplete combustion. That is the only reason it will lead to produce a carbon soot particles, which will produce the major pollutants of atmosphere. So which will cause us extremely dangerous diseases to the organisms. So, and you can remember, I will say as it is the situation. I will say you long back in our India only, one mother. Actually, it is a winter season. She has been slept with her daughter, two daughters, two children, by closing all the windows, everything, and burning the firewood inside the house. You might be noticed in some North Indian houses, or if you might be watching Hollywood movies and all. Always the firewood is burning inside the home. Is it yes or no? Everybody?
Yes,
Yes, sir.
Yes, sir.
To control the heat, that is what, to maintain the home temperature, as it is extremely cold, freezing countries and all, like cold countries, so they used to burn the firewood inside. So now it is happened in our India only. So this lady also burned the firewood in the center of the house, and she slept near to that. What will happen means, when she is sleeping, she not arranged proper ventilation for the inlet and outlet of air, so that the oxygen sufficient is not proper, oxygen availability is not proper in a house, because combustion reaction is taking place, as well as respiration also, they are also taking the breathing. So instead of incomplete combustion, instead of releasing carbon dioxide, the most dangerous gas is released. What is that gas?
Carbon monoxide.
monoxide.
Carbon monoxide. So by morning, along with her two daughters, she also passed away in sleep itself, without knowing them they are going to die. So that much extremely poisonous gas. That is what we will say is a silent killer. Carbon monoxide is the silent killer. Just 5% of our breathing volume of air. Do you understanding? If I'll breathe one time, in that, if it contains 5% of carbon monoxide, just it will leads to directly death only. So there is no other kind of even short treatment also, because this carbon monoxide directly react with our RBC. RBC also contains something. What is that called as? All of you.
Hemoglobin.
Hemoglobin.
Okay, and make the hemoglobin to form into a solid balls, so that is what we'll say carboxy hemoglobin. Carboxy hemoglobin, so that it will turns into a solid balls. No transportation of blood, so no transportation of oxygen. Finally person will leads to death, even without knowing. That is what, in sleep itself they have been passed away. So that is why always when something is burning in our home, always we have to remember proper ventilation has been arranged. Even gas stoves also, if there is no ventilation, then it is extremely dangerous. That is the reason you have to remember. So the main problem, if you have taken, if it is incomplete combustion of this one, mainly like this alkenes and alkynes, unsaturated hydrocarbons. So they used to produce the soot. Soot is very, very dangerous. And also you can see that it will it will blackens the cooking utensils, everything. And you can see that incomplete combustion leads to the formation of poisonous gas, carbon monoxide. And another disadvantage that incomplete combustion of fuels always produces less heat energy or more heat energy. Less or more? Yes, please. Less heat energy. Do you understanding? Less heat than the complete combustion. So always leads to huge consumption of fossil fuels. Because if you want to produce the heat energy, what you want, required heat energy, you need to burn more fuel because they will produce only less amount of heat energy. So that is the reason. Even one surprising thing I will say you, it is not in chemistry, physics I am saying. You might be hearing our bikes, cars and all, two-stroke engine, four-stroke engine, like that nowadays five-stroke engine is coming. Yes or no? Five-stroke engine, four-stroke engine and all. Is it yes? All of you? So this all the engines will work with the principle called as Carnot cycle. You might be don't know. So this is the Carnot cycle approximately 120 years before, means almost 1 century before it has been invented by Mr. Carnot. Till today, we are using the same engine design for making all our bikes, cars, everything. Four-stroke, two-stroke, and five-stroke engine. Carnot cycle, we used to say. So the maximum efficiency of this Carnot cycle till today is only 20%. From the 101 to 120 years to till today, we are not going even advanced than that. Nobody has been invented. Just if I am using one liter of petrol or diesel, imagine only 20% of that petrol or diesel is using for producing heat energy, and it is using for running the vehicle. Remaining all the 80% is only emission of what? Emission of what, guys? Emission of smoke and other harmful substances for the atmosphere. So that is what is happening. So once imagine if you will develop an engine which will produces zero emission of carbon emissions, zero carbon emissions. Do you understanding? So that is what even G20 summit of last week, which is connected by our India, which is hosted by our Honorable PM Narendra Modi. The G20 summit has been also told by the 2000, means 2100, all the countries need to stop zero emission. That is what even their motto also. But it is extremely impossible unless the fossil fails over. So if the engine efficiency, what we are using the present automobiles engine, efficiency is increases at least 20 to 40, maximum percentage till today we are obtaining is 40 percentage. If we are able to use 100%, then it will leads to carbon emission, zero carbon emission. Then this environmental cannot be polluted this much. But of course, so much research is going on, but still nobody can bring the efficiency more than 40%. Highest percentage which we can obtain with the help of Carnot cycle is 40 efficiency. So that is the reason we are running out of always fossil fuels, and as well as leads to extremely natural disasters and all because of our actions. So this is what a lot of disadvantages of incomplete combustion, and it is extremely dangerous also to our nature. So this is how a incomplete combustion can be converted into complete combustion by presence of pure oxygen. Okay. Now let us go to the first reaction is this one. Now the second type of reaction, some of the chemical properties of organic compounds. Second reaction. Anybody? What is the second reaction, guys? Everyone,
Substitution reaction.
substitution reaction. Write it. Combustion, anybody having doubt? Please ask me. Substitution reaction. Okay. So now, this is the most important reaction. Of course, combustion also, but more than combustion, substitution reaction is very important. So let us comes to the saturated hydrocarbons. Who is saturated hydrocarbons? All of you? Yes.
Alkene.
Now, if we'll take the substitution reactions, all of you remember, let us take a saturated hydrocarbons. All of you should tell me, saturated hydrocarbons means, who is the examples, guys? Saturated hydrocarbons means alkene. Okay, so now these alkanes having single bond or double bond or triple bond. All of you, carbon contains one bond. Carbon contains only single bond. So because of single bond, they are less reactive or more reactive. Anybody tell me? Yes, please. All of you.
More reactive.
No, they are unreactive or very less reactive. Do you understand, Elmukil, what I'm saying? So because of carbon single bond, very important reaction, substitution reaction. Because of saturated hydrocarbons containing the carbon single bond, they are very unreactive, quite unreactive, or they are low reactive because they do not react with the many substances. Do not react with the many substances because of carbon single bond. So saturated hydrocarbons, however, they will undergo the substitution reaction with one of the halogen non-metal. Anybody can tell me, guess at least?
Chlorine.
Chlorine. Very good. Super. So even though they are very less reactive with substances, very few only they will react. In that, one of the most substitution reaction which will happen with the chlorine in the presence of sunlight. So that is why substitution reactions of saturated hydrocarbons you can take. For example, what is the first family member of alkane? Everybody, all of you. First family member of alkane. What is that? Methane. So methane and chlorine. Chlorine, if you react, basically they are very less reactive with the chlorine. We should know that is it is called as, if I am reacting the methane with the chlorine, then that is called as substitution reaction. So why it is called as substitution? Let us discuss it is. So if I have taken a reaction in which one or more hydrogen atom of hydrocarbon are replaced by some other atoms, that is what heteroatoms. Who is the heteroatoms? Can anybody tell me? Who is the heteroatoms? Functional groups. You might be notice it. Heteroatoms we studied. Heteroatoms. Do you remember that? Hydrogen is replaced with the chlorine, bromine, iodine, fluorine, oxygen. Then this all these elements is called as what? Heteroatoms. Do you remember that? Hydrocarbons, one hydrogen or more than one hydrogen, if I'll replace with this understanding halogens or some other non-metals, that is what we used to call as substitution reaction. All of you, are you clear what I'm saying? So in any kind of alkanes, if I am replace the hydrogen with some of the other elements, that reaction is called as substitution reaction. So if the substitution of hydrogen atom takes place by chlorine, then that process is called as one of the process which we used to see in the filtration of water. What is that, anyone?
Chlorination.
Chlorination. That is what you have to remember. If the substitution reaction is characterized by a property of saturated hydrocarbons or alkanes, then remember the substitution reactions of saturated hydrocarbons with chlorine only takes place under the presence of sunlight. So when I replace this one hydrogen or more than one hydrogen with the help of some other atoms, then that reaction is called as substitution reaction. So one of the most popular reaction with the saturated hydrocarbons and other non-metal called as chlorine is called as chlorination. So that is why substitution reactions are a characteristic property of saturated hydrocarbons, or we used to say alkanes. So that is like you can take methane reacting with the chlorine under the presence of whom, guys? Methane formula, fastly everybody. Methane is CH4 reacting with the chlorine gas under the presence of whom? Under the presence
Sunlight.
of sunlight. So what is the products will come? Anybody can tell me? Yes, please. We all know.
Cl2, Cl2.
Yes, it will form chloromethane. Everybody should tell me what is the formula? Chloromethane. CH3.
CH3Cl.
Cl.
Yes, along with that, we are going to get hydrochloric acid. So this is what is the reaction will takes place. So anybody tell me balancing? Is it balanced already or is need to balance?
Already balanced.
So this is what methane. So methane, if you have taken reacting with the chlorine under the presence of sunlight, so it will be one hydrogen will be replaced with the chlorine. That is what we used to call as. What is the name of this one? All of you. Chloromethane. You might be remember first kind of functional group. What is the first functional group, guys? All of you. First functional group. Nobody? Halo. Understanding. That is what you have to remember. So halogens, we have to add haloalkenes. We have to add prefix or suffix.
Prefix.
Chloromethane plus HCl. It is a gas state. So what is the HCl name? If it is a gas state, what we used to call?
Hydrogen chloride.
That is what we used to call as substitution reaction. So one hydrogen atom of methane has been substituted or replaced by chlorine atom and will be converting into methane, converting into chloromethane. So this chloromethane, what is the IUPAC name? Anybody can tell? Sorry, common name. This is also I taught you. Chloromethane common name. What is the common name? Everybody? I have written already even. At least learn that.
Methyl chloride.
Methyl chloride. Okay. Chloromethane, methyl chloride. Write it. So this is what we used to call as substitution reaction. So just one hydrogen or more than one hydrogen is replaced with some other thing, then that is what we used to call as replacement reaction or substitution reaction. But basically in alkanes only we will study this one. So whenever we are replacing one or more than one hydrogen with some other, that is what we used to call as substitution reaction. Write the definition. The reaction in which one or more hydrogen atoms of a hydrocarbon are replaced by some other atoms. What is the example of some other atoms, everybody?